Hey y'all, time for section 2.3, two-column inference change. What we're about to do is this. We're about to do the kind of work that we did in the first two sections, but we'll put it together in the form of a table. That is, if you recall from sections 2.1 and 2.2, we had what I'll now call atomic inferences. That is, we had one statement that followed from a second statement. What we'll do here in this section is we'll put together multiple instances of this where we'll perhaps have um, a second statement that follows from a first, and then a third statement that follows from a second, and so on. And then we've got a nice way to put this together in table form. So let's take a look at this. So this is very close to proof, but not yet quite proof, or I won't call it proof anyway, because we're not really ready to take that on. But I do want you to understand that what I'm about to show you, how it is that we can put multiple inferences together, um, is very much like a proof, is really essentially a proof. But we'll hold off on that language until the next section. Next chapter, I should say. All right, we'll organize all of our work initially in two-column form. That is, we'll have a table that consists of two columns. On the left-hand side, we'll have statements or claims, if you like. And on the right-hand side will be the definition or postulate by which each statement follows. We call the first statement the given. Sometimes we have more than one statement that is called the given, but we will always have a given in the tables that I will show you, because that's simply where we begin. And I will allow myself to begin to use abbreviations, and I will choose abbreviations that I believe you will find are clear. All right, so if all of what I just said made little sense to you, I think it's about to make good sense to you once we have particular examples. So here's our first table. Notice that it does consist of two columns. On the left-hand side, we have statements, which sometimes I call claims as well. Those two words are synonymous. And then on the right-hand side, that is in the right-hand column, we have a definition or a postulate, okay, after the given anyway. And what that definition or postulate tells us is how it is that we get from a previous statement to the statement that we have now on a particular line. So let's take a look at this. So our initial statement is 2x equals 12, and that's simply the given. So you don't ask where that comes from. I provide that to you, and then we work with that. And then notice what happens on line number 2. We took the statement that was on line number 1 and divided both sides by 2. So 2x equals 12 became 2x over 2 is equal to 12 over 2. So line number 2 came from line number 1 by division, or if you like, div. So this is the kind of work that we did before when we recognized that one statement did follow from another, and we said why it followed, that is what definition or postulate applied. But now we just simply organized it in a different way. And now look at line number 3, which says that x equals 6. Yes, indeed, that does come from line number 2. And the way that we get there is by substitution, which I will abbreviate very often as SUBST. So the 2x over 2 became x, and the 12 over 2 became 6. And as I told you, that kind of simplification work we call substitution. Okay, so there's our first table where we have multiple atomic inferences, the atomic inference that got us to line number 2, and then the atomic inference that got us to line number 3. All right, let's take a look at another example. So we have B lies between A and C. Of course, these are points. And I tell you what, let us draw ourselves a picture. In many instances, I will provide a picture for you, but in some I will not. And in those that I do not, I highly suggest that you draw a picture for yourself. It helps you to avoid mistakes and to understand what has been said. So we are told that B lies between A and C. Okay, so that means that we have a segment. Oops, that's a mess. We have a segment AC. Okay, so I'll draw you such a segment. So we will have a segment AC. And once again, we have a mess, so I will take care of that. So we have the segment AC with B between. Okay, so B lies somewhere in between. Now, it might turn out that my picture isn't really accurate for the values that are given, but that kind of accuracy doesn't really matter. We just want to make sure that we understand that B lies between A and C. Okay, so we know that AB is equal to 3, and we know that BC is equal to 8. And yes, a BC does look longer than AB, but that doesn't really matter. This diagram only helps us to keep up with information. It isn't supposed to look accurate in that way. Okay, so that's our given. And then let's see. We're told on line number 2 that AC is equal to AB plus BC. Oh, that says that the whole segment AC is the sum of its two parts, AB and BC. And that is the segment addition postulate, which we will call simply SAP. And then let's see, how do we get to line number 3 from what we had before? And you must keep in mind that the new statements in one of these tables doesn't simply drop from heaven with no reason attached, but every new statement after the given follows from some previous statement. And to understand one of these tables is to understand from what prior lines it follows and by what rule, that is, by what definition of postulate. So let us ask ourselves about line number 3. From what previous line does it follow, and by what rule does it follow? Well, we get to line number 3 by a change in line number 2. What changes that? Well, AB turned into 3 and BC turned into 8. And we can do that because on line number 1, we were told that AB is equal to 3 and BC is equal to 8. So really, we made use of lines 1 and 2 to substitute into line number 2 to get AC is equal to 3 plus 8. So that is substitution. And then finally, that 3 plus 8 collapsed down into 11. And that kind of simplification of work, again, we call substitution. All right, so here's a third, which will perhaps seem a bit more geometrical, or at least it involves angles in this case. So let us say that the measure of angle 1 is equal to 120 degrees, and that angles 1 and 2 are supplementary. Notice really the given is in this case 2-part, which is entirely possible. The given can have as many parts as you like. We could even, if we had wanted, have split the given over the first 2 lines of the proof. We'll do it differently at different times. Okay, so line number 2. Line number 2 says that the measure of 1 plus the measure of 2 is 180 degrees. Well, how do we know that to be true? Well, we took the statement on line number 1 that angles 1 and 2 are supplementary and applied the definition of supplementary to it. And that definition says that supplementary angles sum to 180 degrees. So line number 2 does come from line number 1 by the definition of supplementary. All right, so line number 3. Again, the question is, how do we get there? Well, we get there from line number 2. Notice the difference between line 3 and line 2. The measure of 1 became 120 degrees. Now the question then, of course, is how is this able to happen? Well, this can happen because we are told in the given on line number 1 that the measure of 1 is 120 degrees. So the measure of 1 was replaced by, substituted for, to get 120 degrees. So, of course, that is substitution. And then on line number 4, notice what we do is we subtract 120 degrees from both sides. So, of course, that is subtraction. And then usually subtraction is followed by a simplification step that we call substitution. And sure enough, that's what's happened. On the left-hand side, 120 minus 120 became 0. So on the left-hand side, we have simply the measure of angle 2. And on the right-hand side, we have 180 degrees minus 120 degrees, which of course is 60 degrees. So that's substitution. And then finally, we declare that angle 2 is acute. And again, let me emphasize that comes from a previous statement or statements in the table. From what does it come? Well, it's really line number 5, right? Because line number 5 tells us that the measure of 2 is 60 degrees, and we know by the definition of acute that such an angle as that is acute. So line number 6 follows by the definition of acute. Now, as I've said, we can split the given into multiple lines if we wish, and I thought I would show you an example of that. I mean, we could put the given wherever we want. We could indeed put the given after a statement that is not the given, though typically we do put all of the given up at the start, just, ultimately whatever's clearest. So here's an example where we have 2 initial statements that are each called a given. And then also let us fill this table in. Now, this is the kind of work that you will have to do in the homework assignment in today's problem set. That is, I will create a table for you. Typically what I provide are statements, and then you have to fill in that by column with names of either definitions or postulates that tell us how we get to that new line from previous lines. All right, so here's the given. First of all, line number 1, angles 1 and 2 are complementary. I abbreviated complementary. And then the second part of the given is found on line number 2, and it is that the measure of 1 is equal to the measure of 2. All right, so line number 3, we are told that the measure of 1 plus the measure of 2 is equal to 90 degrees. How do we know to say this? What justifies this? Well, what justifies this is line number 1, which tells us that angles 1 and 2 are complementary. And of course, we know that by the definition of complementary angles sum to 90 degrees. And then Line number 4, how do we get there? Well, that's a transformation of line number 3. Notice that the measure of 2 in line 3 becomes the measure of 1. And why can we do that? Well, we can do that because of what is found on line number 2, that the measure of 1 is equal to the measure of 2. So what we did is this, is we substituted the measure of 1 for the measure of 2 in line 3. So that follows by substitution for sure. And then line number 4, compare that to, line number 5, compare that to line 4. It is the same, except that we now have twice the measure of 1 instead of the measure of 1 plus the measure of 1. So what we did was we replaced measure of 1 plus measure of 1 by twice the measure of 1. And that kind of replacement, which does simplification work for us, is substitution. And then what happened on line number 6 is that we took line number 5 and divided both sides by 2. And you've got this, right? We get to new lines by some manipulation with previous lines. That's just how these tables are put together. You must always look at the previous portion of the table to find out how we got at this new line. So line number 6, we get there by, we take division. We use division on line number 5 and divide both sides by 2. So this is the division postulate, which I'll just simply call div. And then notice what happens on line number 7. The left-hand side, which was twice measure 1 divided by 2, that became simply measure 1. On the right-hand side, 90 degrees divided by 2 became 45 degrees, and that kind of simplification work, where we replace an expression by what it equals, that is substitution. And then finally, we get to declare that the measure of angle 2 is equal to 45 degrees. Well, how do we get to do that? Well, look at these two previous lines. The measure of 1 is equal to the measure of 2, line number 2, and the measure of 1 is equal to 45 degrees. That is line number 7. If both of those are true, then it must follow that the measure of angle 2 is also 45 degrees. And that I will call the transitivity of equality. It could also be called substitution, but I love to call cases like this transitivity of equality because, well, it really is transitivity, right? We have two quantities, each equal to the same quantity. That is, 2 is equal to 1 and 45 degrees is equal to 1. And then it follows that those two must equal one another. That is, the measure of angle 2 is 45 degrees. And with that, the table is complete.